We'll call this brief pencast Fun with Arctan, and it comes from today's lunchtime free response practice where we had to integrate f of x as we see up here. And I mean, the part A deals with it being an improper integral. We know how to do that. We anti-differentiate, set the top limit to a dummy variable. You can use b since the top limit is b, or L, which is my variable of preference, and then just set the limits as L goes to positive infinity and go from there. But the focus of this is how to anti-differentiate it. You would think, after all the mechanical integration practice that we had, we would have seen everything. Well, this one caught me by surprise too. So the focus will be how to anti-differentiate this one. So we look at it, and just sort of a mental checklist would tell you, is the denominator factorable? No. So partial fractions is out. Straight up U substitution? No. That's out. Known derivative form? No, that's out. Integration by parts? I doubt it. I haven't tried it. But what I think we're all looking at, and of course the title of this pencast, is that kind of sort of looks like arctangent. Well, you are correct, and the job is to make it look like arctangent. Well, we know that arctangent has the form 1 over x squared plus 1, or g prime over g squared plus 1. Well, neither one fits here. The 9 is creating the problem. Well, whenever we have a number that's creating a problem, let's just factor it out. Don't bother to say, oh no, I can't factor it out of x squared, because given all of our experience this year, you can factor anything. So just force it out. So we have 1/9 times, that's going to be 1 over x squared over 9 plus 1. So we're looking closer and closer to this form, or this form, honestly, that form. So I still can't see how to make this arctangent. Well, first things first, let's put the dx on and pull the 1/9. And moving on. So again, focusing on this form, is there a g of x such that g squared of x equals x squared over 9. And that would be my first recommendation, to look for a visual cue that the process might be the fun with arctan process. And what I'm focusing on is this right here, that is a perfect square. Because when it comes out, it leaves you this. And then x squared, of course, is a perfect square. So the 9, or if it were a 16 or a 25, is a perfect square also. And we can answer this question over here in green. And that is, yes, g of x equals x over 3. Then this integral becomes 1/9, boom, 1 over x over 3 quantity squared plus 1 dx. Leading me to the u substitution, which is really taking the answer to that question and going for it. So I got 1/9 integral 1 over x over 3 squared plus 1 dx. Let u equal x over 3, making du dx equal to 1/3 cross multiply 3 du equals dx. So when you put 3 du in for dx, the 3 comes out, and you get 3/9 integral 1 over u squared plus 1 du, and you're home free. From here, it should be obvious. We're going to get 1/3 arctan u plus a constant, since we're really doing an indefinite integral. We weren't in the free response question, but for this explanation we are. And then we have 1/3 arctan x over 3 plus c, and you are done. Happy face. So I guess the takeaway would be what we talked about before. Is this x squared? And is this a perfect square number? If it is, force it out. Then you're here, and forgive all the arrows you're answering that question. If the answer is yes, you're also looking at your U substitution. So yet another with all the mechanical integration techniques and Mojo and voodoo math. Here's one more to think about. Fun with Arctan. Tori out.